dealing with bicycles and
I'm Johanna, and my thesis project was about the potential for bicycle commuting among Willamette University's employees. I'll begin by reviewing what I talked about last semester in my proposal. Basically, the benefits of bicycling are that they don't emit greenhouse gases like cars do, so it's good for air quality and don't contribute to global warming in that way. And the better air quality and added exercise are good for human health and of people doing it and people enjoying the air. Bicycles are very economical, especially now with rising gas prices. But right now there are very low rates of participation in the United States. In Oregon, 1% of commutes are 1% of commuters are doing it by bicycle, and the highest city in Oregon, city with the highest rate is Corvallis at 8%. That really pales in comparison to countries like Europe. Areas in Europe and China, places like that where it can be up to 30% of commutes by bicycle. So I wanted to look specifically at Salem and the Willamette community. Salem, as you know, is right here, in between Portland and Eugene. There's approximately 150,000 residents. My specific population I looked at was the faculty and staff of Willamette, which included the College of Liberal Arts and the Law School, Business School, and School of Education. And there were about 820 employees, and I chose this focus eventually on just the Salem and Kaiser residents. And I picked this population because I was able to gather information about them, and they were fairly stable. There wasn't a lot of, didn't imagine there was a lot of turnover from year to year. So my specific objectives were to look at how many people are currently commuting by bicycle in the study group, and so how much CO2 emissions are they saving by not driving to work. And I wanted to take a theoretical look at it, say how much more CO2 emissions could be saved if more people were bicycling. So to complete my objectives, I had sort of three separate branches of my method, which were a GIS to map and analyze the distribution of the employees and find out where they live. And I would send out a survey to the group to find out what their actual commuting habits were. And I also would do field testing of the routes, basically to compare how long it takes in a car versus how long it takes biking, taking into account that they would be done during commuting time and stuff. So I'll go into each of these a little bit more. My GIS analysis, I was able to gather addresses from Willamette's Busser's Guide, sort of like a phone book, I'll show you now. I was only able to get 390, which was about half, because it is voluntary if they put their address up there or not. So I plotted the points on my GIS, and the ones that were in Salem and Kaiser were about 280. So I plan to look for neighborhood groupings to see where the concentrated areas where these people are living, and then use those to pick the routes that would be in field testing. And overall, just present all my findings in the GIS. The commuter survey, it was online and distributed by email. I asked questions about how far they live from the campus, how do they usually get to and from the campus, classify themselves as biking almost always, biking often, biking occasionally, or never biking. And as it turns out, there are a lot of people never biking, but always walking. We'll talk about that later. And I would later evaluate that in terms of the carbon dioxide that was actually being saved by these people. And my third part of my method was my field testing. So I planned the routes using info from the GIS, as well as city bike maps and online maps to sort of determine what the best road would be to take. I drove the route in a normal passenger car during normal commute time periods to see, and timed it to see how long it took me, given how much the traffic slowed me down. And later bike the same route, which usually wasn't actually during commuting times, but to compare the time duration. So I think the best way to show you the results from my GIS is to give you all the great visuals that I was able to make. These are the 280 homes that I was able to get the addresses for Willamette employees in Salem and Kaiser. And so, as you can see, they're not particularly clustered very tightly. So I had to use a tool in the software, the spatial analysis density function. It gave me this, which showed me, so I could begin to see the clusters of where people actually were based on the density. So going from green to red is increasing density. So I had to pick out the center of each centroid, as I call them, the larger blobs, in order that I'd have an actual physical point to bike to in the center of each place. So that's what I chose. Then I had to establish the routes, and I tried to make them as viable as I could for both the car and the bike. So it was mostly major roads that had bike routes, and so according to people's personal preferences, they might pick different routes. But so here is just the routes and the points, the addresses or intersections of all the points in case you were interested. As we zoom in, you can see my destinations on campus were parking lots that also had a bike rack and were closest to the directions that I was going to. So I have the UFs and Law lot, Sparks parking lot and Matthews parking lot. And the similar colored routes are sort of morning and evening. You can see that they differ mostly because of one-way streets, and so like how you can go south on Commercial, but you have to come north on Liberty. So those two brown routes are the same commute, but you have to go different ways. So what were my actual field test results? This is a simplified version of my actual results. I have a lot of times and average speeds and things like that. And I've actually been able to complete a few more of them. So I should have been able to fill this in more. But I want to point out to you that there are two instances in green where the bike ride tied or beat the car ride. They're kind of at different distances. One is under a mile and the other is 2.2. And then there were 3 times where the bike ride came within 150% of the car time, so under time and a half of the car ride. And I think it's interesting that all these were in the evening commute, when traffic really was slowing the car down quite a lot. I picked which times to go by basically looking out of my window at Pringle Parkway. And when the cars already started backing up towards the hospital and they were at a standstill, like a block away from the light, and I knew it was time to get in the car and go. And so I think I may have gotten better results in the morning if I was able to understand when the peak time of traffic was in the morning commute, but unfortunately I had to be in class at 8 a.m. every day, so I didn't have a lot of flexibility for choosing the most traffic-ridden commute time in the morning. But mostly what I want to show you is that the bike can be plenty fast. It's not even twice as slow as a car most of the time. Most people probably imagine that it's slower than it is, but at these close distances, the bike can be a pretty quick way. So for my commuter survey,